Welcome back, everybody, to another session, the A4Q Testing Summit Edition 2025. And I know we've got a very exciting presentation for you now with Mesut Durukal, who is a QA engineer, senior QA engineer in test automation with Indeed. Mesut, I'm going to pass straight over to you and ask you to start your presentation.
Thank you, Debbie. Thank you so much. And hello, everyone. Again, my name is Mesut Durukal, and I'm a senior quality assurance automation engineer. Since we are already talking about the quality, in this session, I will discuss something about bugs, the bugs that we might have in our products or the software that we are developing and delivering to our customers, because there are lots of different things that we can relate to quality, right? But bugs are one of the very direct indicators of the quality. It's not only the number of bugs. Of course, the more bugs, the number of bugs in the product, the less quality probably. But I'm saying probably because it's not only the number of bugs, but also there are lots of different dimensions or the aspects of quality, like the severity or the criticality of the bugs, or maybe not only bugs, but lots of different aspects like maintenance issues, maintainability, portability, scalability, lots of different aspects, right? But again, bugs are one of the very direct indicators of the quality. So we will discuss this because why? By analyzing the bugs, we can collect lots of different insights about the quality, not only the quality of the product, but also quality of the process as well to develop that product, the way to develop that product. If we collect some insights about some improvement rooms that we can apply on the way, on our approach to develop that product, then we can not only in the short term, but only also in the long term, we can improve our both the product itself and the processes which we will apply to this specific product and all the products that we are developing, right? So this is what we will do. And how we will do is, of course, there are lots of different ways and approaches we can apply, but eventually I'll discuss getting some help from machines, from machine learning algorithms, right? Because nowadays it is always a hot topic to get some help or support from the machines or the machine learning algorithms. In that way, we can get rid of or eliminate some manual efforts and facilitate our processes to make it more productive or more efficient. So this is what we will discuss and how we can manage. So again, by analyzing the bugs, by fixing those bugs, of course, we will be eliminating the weaknesses or the vulnerabilities in the product. That will already a short win, right? It will already improve the quality. But also, if we find out some improvement rooms, for example, if we are somehow missing a test type or a test stage in one part of our development processes or in our software testing life cycle or even a software development life cycle, then we can already apply and improve that process as well. So these are the two dimensions of benefits of doing this bug analysis. So when I am saying bug analysis, then it means I'm saying collecting some insights from bugs, right? So what I'm mentioning here is somehow building a communication with the bugs, talking to bugs, like asking some questions and getting some answers. Because in this way, if we ask the correct questions to the bugs, to reported bugs, then we will have lots of different significant answers. I have lots of different stories around this communication. Like once I had a bug which was open for a long time. And when I figured out, when I dig into the report, then I found out why it was very old. It is, I'm saying it is the story of a old ladybug. Because it was open for a very long time. Normally, it was supposed to be managed and transferred to somewhere else, but it was still in production environment. So it was very old in that environment, and I managed to understand the reason underlying why it is very old and it was not managed properly. And similarly, I have a story around the sweet escaped, which means it is the story of an escaped bug. An escaped bug is a bug which was not caught in testing activities or even the development activities, but it was somehow escaped to production environment, because normally we try to close the gates, right? We try to block their way going to the production environment. We don't want them over there. We just try to manage them in the testing environments or the development environments. But uh, one bug somehow managed to find a way going to production environment. When I asked correct questions, I found out how it managed to escape to production environment. What did I miss? Because I thought my coverage was okay. I tried to cover all the use cases. I tried to cover all the corner cases, but somehow one bug managed to escape to production environment. So by asking these kind of correct questions, we will be finding what we are missing, how we can even improve our processes and the testing activities. So again, when we are talking about asking the correct questions, what kind of questions we can ask to the bugs? These are the 5W and 1H questions, like what, under what conditions did this bug raise? Or where did it happen? And in what environment? While using which browser, in which operating system, or all the environmental conditions, where did it happen? And of course, why? Right? This is one of the most critical questions. The root cause analysis. Why did it happen? And who triggered? Which user, which profile? And how it happened and when it. All these kind of similar questions will lead us to very important knowledge and the information that we can collect from these reported bugs. Let me explain you what we have to do this analysis in the proper way with an analogy. Like when we are waiting in the airport for our flights, if there is a change in the flight, then there is a risk to miss the flight, right? Because we might be waiting in the wrong gate. There is a wrong gate change, but if we do not get this information, somehow collect this information, then we may miss our flight. There's a big risk. But why may we miss this information? For example, if they don't have enough platforms, like if they don't have any screens to show the notification, or if they don't have any loudspeakers to make this announcement, then I will not be seeing or I will not be hearing this message or the notification or the announcement. It means the visibility or the transparency is missing, right? So which means we have to prepare our environment. We have to prepare all the manage all the tooling that we will use to transfer the message, or we will use for getting the information from the bugs. Then if the announcement is made only in one language that I don't speak, for example, something is told over there, but I don't understand anything, right? Because I don't know this language. So similarly, if we are using the wrong language while communicating to bugs, then it will not work out. Because somehow we have some data, but it is raw data, and we are not using the correct decoder to turn this into valuable information. This means maybe we have formatting issues, or we are not using the correct protocol or the correct communication channels to make this to build this communication between the communication to the bugs. And finally, if the announcement is in the correct language and there's a proper environment to transfer this message, there might be still some problems. Like, okay, I can understand, I can pick some words, but I don't really hear what they are saying, because there is too much noise in the background, right? If it is too noisy, then it's a big problem for me, because I will not be understanding fully. Which means, converting this analogy to our situation, if data is not clean, if I'm not applying this noise elimination processes, then again, I will not be reaching to the valuable information. I will be dealing with lots of different noise, which will block me, which will hinder the correct or the valuable information that I will need. So there are several ways to prepare our environment. First of all, what we can do is maybe customize our environment or the tools that we are using. For example, whatever test management or the project management tool that we are using, for example, let's take Jira. It is one of the most common tools that is used, right? So if that is the case, most probably there is a default workflow, right? There's a default life cycle. Like the issues are starting from new status and then in progress and under review and finally closed. Or a similar one, like 3-4 steps or status. But I can customize this workflow or the life cycle to increase or to improve the granularity. Like I can add more status from after new, it was just after just the report was created, I can add some more status like assigned or maybe not assigned, but there might be several reasons since the issue is not assigned but somehow closed. It might be rejected. It might be decided as not a bug but a feature, as we all know, the main trouble of the testers. And or it may be deferred, like it is accepted, but it will not be resolved immediately, but later in the some next stages in the project. So in this way, we can understand under what status we are spending too much time, or from which steps did the bug go through. So this will improve our transparency and the visibility, as we discussed in the previous slides, with the analogy of waiting for our flight. Next, we can of course do this monitoring activities or the querying manually. But of course, doing this query every day manually is not easy, right? It's cumbersome. There is too much effort we have to spend on this. But if we develop a code doing this query, then we can easily create a job which is running this query and calling the APIs of the management tool that we are using. It can already do this for us. It will give the same results. Like instead of navigating to the relevant web page and doing the query over the UI of the pages, we can just write the code, which is pinging the API and getting the response. And furthermore, we can even parse the result, parse the response to get some certain fields from the response automatically. It will be much more easier. And of course, it will be faster. Like if we parse the response from the servers, then we can check when the issue was created, the creation time, right? And when the issue was resolved, the resolution time. And even by doing some calculations like subtracting the creation time from the resolution time, we can reach out to time we need for resolving this bug. And eventually, by collecting lots of different issues, we can calculate even the average resolution time. Like in average, how much time are we spending to resolve our bugs in this environment? This might be a relevant information. So what kind of metrics are important for us? This is another question that we will discuss in the next slides. There are too many metrics that we have to decide which one is the correct for us. But again, this might be just one metric or one information that might help us to improve our processes. Finally, after collecting all this information, showing them on some different dashboards or charts or graphs will help us understand what's going on in our environments. Because numbers are great, they are telling a lot of stories. But visually, by showing them on the dashboards or the graphs, it will be much more easier to understand, to figure out if the trends are going higher, if the limits are violated, we can set some limits, right? And whenever those are violated, then we can even set some alarms, notifications. They can send some emails, or they can just send a message in our Slack channels. So these dashboards and the monitoring tools will help us to easily analyze the progress in our environments and all the violations that we have to take care of. So in the first stage, we discussed a lot about the benefits of doing bug analysis and the preparations that will help us to properly manage this communication and the analysis of the bugs. So after or during this analysis, what kind of information I can collect? Let's a little bit talk about this. There are several metrics that I can go through. And if you ask me which one is the most important, as a regular answer, the answer would be it depends. Because it depends on your requirements, it depends on your purpose, what are you trying to achieve, what are you trying to improve. Like if you are trying to improve the resolution time for the bugs, then of course you can collect some relevant metrics. But if you are trying to reduce the number of bugs escaping to production environment, then you can collect some other relevant metrics, right? So it depends. First of all, please clarify your goals. And then we can decide what will help us to achieve our goals. But I will share you lots of different metrics which may give some insights to perform your monitoring activities. For example, bugs distribution over their status or the severity levels. For example, what percentage of bugs are in open status or in progress? In short, they are not closed, they are not verified yet. So that if we do this monitoring activity in every sprint, then we can understand if the technical debt is increasing or not. Like most of the bugs are still not verified, so that we can go and talk to the development teams and try to understand why they are still not resolving those bugs. If that's a capacity problem or if there is some more critical issues which has to be resolved, so that this might be a decision criteria to freeze the new implementation issues, right? If there is a time to stop the development activities, to not to implement new features, but first of all get rid of the existing issues or the bugs, then this kind of monitoring activities will help us to take this decision. And similarly, we can understand if we are finding mostly high severity bugs or the low criticality bugs. So again, in this way, if most of the bugs that we are finding are low criticality bugs, then we can maybe change our perspective, right? Try to find some more critical bugs, some more major bugs. It might be just some idea to change our testing perspective or the way to conduct our test cases. One more example of or metric that we can show or monitor on the bugs is bugs found on the module or the components or the unit on which the bugs were found. For example, on this slide, I have a microservices architecture and there are lots of different services. And I show the percentage distribution of all services. For example, on a specific one of them, let's say I found half of the bugs from one certain service. I have 20 of them, and only one of them is raising half of the bugs. Then it means something is wrong with the service, right? Maybe I did the deployments not in the correct way, or maybe I even forgot to add my automated test cases in the CI/CD pipeline. So again, I can find the root cause, but it will already trigger some notification about the service. It will already help me to go over and investigate what is the issue with that service. Because again, I'm not expecting exactly the same distribution over each service, but at least like a similar range, right? If I have 20 services and only one of them raising half of the bugs, obviously there is something wrong with that. So I'll be already collecting some valuable information and some insights about the improvement rooms. One similar metric is the bugs distributed per their type. Like mostly I'm having the functional bugs, or mostly I'm having some security bugs, and it may be changing over sprints as well. Like this sprint, we have mostly security bugs. Why? Maybe we change the security algorithm so that maybe it's weaker than the previous one. There are lots of different examples we can go through, but again, just showing them may give some insights about the processes and the approaches that we develop our product. These are all lots of several examples. For example, one other is bugs detection progress, how many bugs, or we can even show them depending on their criticality levels, and maybe not only the detection rates, but also resolution duration. And even we can show the gap between these two, which will give us the technical depth, right? If the number of detected bugs are increasing and increasing in time, where the result bugs are going in a steady trend, then the technical depth will increase. And of course, not only the pie charts or this kind of line graphs, but also we can create some tables like open bugs distributed over their ages. For example, it is still open. There is a severity 1, which is the highest severity or the criticality level, which is open for, let's say, 60 days. Normally, as a team, we can set a goal. Like if we have criticality 1 bug, then let's fix it in one sprint, within the sprint, which means 14 days or 10 days, whatever, 10 working days. But if it is open for 60 days, it means it's already like maybe 5, 6 sprints, right? So we can already detect this over this table, and then we can go to the relevant bug and try to understand why it's still not resolved. Similarly, this time not the open bugs, but also result bugs, but not verified. This time, instead of development team, we can go to the testing team, the verification team, and ask them, guys, this bug is resolved, but it's not verified yet. Why you didn't verify it? Is there a problem with the reproduction of the bugs? Or is there a problem with the verification of the bug? Like maybe the fix that the development team claims is not working properly, right? So maybe you have to reopen it. Please do not waste too much time. You don't have to wait in the closed or the resolved status, but set it back to reopened. We can do these kind of notifications after analyzing these kind of bugs, waiting for verification. But after all, again, I repeat myself, this is one of the most important ones. Escape bugs are the bugs going to our production environment. Because if we are doing testing activities for what? For giving or getting some early feedback, right? But if we cannot find our bugs in the early stages, then it means we are not getting early feedback. So it will already go to the production environment, and it will be already very expensive to fix the bug because it is already on the working software, working code. So I cannot change it anymore. I mean, the whole algorithm I cannot change. Of course, I can fix the code to get rid of the bug, but again, it will be too difficult, too expensive, because again, we are doing the testing for receiving early feedback, and if our test cases is not capable of catching these bugs, then it is time to go and check ways to improve our test cases. How can we understand the capability or the capacity of our test cases if they are good enough to catch the bugs? Again, there are lots of different ways, but I can recommend applying some mutation testing. Like intentionally add some mutants, add some issues inject some issues into the code and execute your test cases to see if they are finding the intentionally injected issues or not. If not, then we should add some more test cases or update or fix our existing test cases to make them capable of catching those kind of injected issues. Finally, we discussed the preparations and the benefits, the introduction part, and then we discussed several metrics that we can collect or analyze over bugs. Finally, in the third stage, let's discuss how we can manage all these monitoring activities or the bug analysis processes by getting some help from the machine learning. So by means of a collaboration between the humans and the machines. It will be a collaborated intelligence. Because in general, machine learning, it's a learning, right? As humans, we are learning. The machine learning and the human learning, our biological learning is very similar. As a tester, if you ask me to test your system, to verify your system, what I'll do first is try to understand your system. What is the system under test? How does it work? What kind of interfaces there are? What kind of inputs and outputs are in the system? And so on and so forth. I will go through all the documentation and I'll do some exploratory testing activities and I'll learn how it works. So similarly, machines, first of all, go through all the documentation, all the information and data and generate a model. And eventually, based on that model, it will predict the upcoming samples or the inputs. Let's see how we can apply on this bug analysis. I will show you what I did in my actual project. So in this project, I had 3 different severity levels for the bugs, and my intention is predicting the severity levels. And if a bug is severity 1, then it's a release blocker for me. But if it is 2 or 3, then it's not. So deciding if a bug is severity 1 or not, or 2 or 3 or whatever, not 1, the other classes, is an important decision because in this case, I can understand if a bug is a release blocker or not. Because if I have a severity 1 bug, then I'll block the release. First of all, I will fix this, and then after it is fixed, I will execute my regression test and see still there are critical bugs or not. So, okay, this is my goal. What did I do for this project is, first of all, I exported my reported bugs from the project management tool I was using, which was basically Jira, and I exported to an Excel spreadsheet, and I have lots of different columns, right? For example, the description of the issue, the assignee, the reporter, several different columns, which means several different features actually. So what I'll relate is the description of the bug, like if the bug is related to some not working services or servers, whatever, that might be a critical bug. Or if it's a cosmetic bug, like a visual bug or a typo or something, it might be less critical, right? So these kind of relations I'll try to figure out and actually ask machines, models to build this relationship and generate their models. So what I did first is cleaning data. Again, remembering the analogy we went through. Cleaning data, getting rid of the noise. Like there are lots of different words that I don't need in the extracted sentence. And there are some different formatting issues I can get rid of. So first of all, pre-processing, cleaning data. And then over the clean data, in the machine learning algorithms, I need to extract the features, right? Feature extraction means like there's a sentence, English sentence, I can understand or the humans can understand, but machines, robots, PCs do not understand that. They understand only numbers. They actually understand only zeros and ones, right? So I have to somehow convert this sentence to some numeric vectors. So how I do this in this particular example is I use the bag of words approach, which means it counts the words in each sentence. For example, if my sentence is this is an apple, I have one this word, one is one and one apple, right? These are the count of the words. And over the whole vocabulary, I mark like this one and some other words in the dictionary happens 0 and is an apple words again 1 times. So I already have a numeric vector, right? Consisting of zeros and ones. So I already have the features so that I can provide this to my model. And I can generate my model by lots of different algorithms like KNN, K neighbors, nearest neighbors, or naive Bayes, K-means clustering, and several algorithms. So I tried all of them. And of course, I picked the best performing algorithm. So let me show you some results. For example, these are the three classes. And on these three classes, I had 73% accuracy rate. But let me go back and ask your attention for this distribution. There's a bias on class 2, right? The first class. So to get rid of this bias, I merged class 3 and 4, the other two classes. Because remember, I told you, if it was the first class, it was a release protocol, but for others, it is not. So deciding if a bug is in the first class or not means all the others, is an important decision for me. So let's merge all the others. So in this case, it will be much more balanced, right? There is not a big bias anymore. So in this case, the accuracy rate now is 82%. Still not perfect, by the way. Machine learning algorithms are expected to work in maybe over 96, 97% accuracy rates. But this is a challenging problem because think about doing the trash of the bugs. It's sometimes not easy, right? I'm saying it is class 2, but another colleague in the team says it's important, it's class 1. Some other says, okay, it's okay to have, we can take this risk, it's class 3. So sometimes it might be subjective and it is a challenging problem. But at least we can use this to facilitate our processes. Again, this is the most critical question, right? Can we replace all the manual processes with the automated or the machine learning algorithms? Maybe we cannot fully replace, but of course we can, in the first place, get some help. Use this and eventually ask humans to take the final decision. But of course, machines will be already facilitating the processes and eliminating some manual efforts that we will spend a lot of time on analyzing all this big data. Not only the classification, but also we can do the clustering as well. We can generate different groups of bugs. Then we can assign the similar ones to the similar teams or the people, or it will give us the chance to manage the bugs in a more consistent and a more easier way. So summarizing all things we discussed, talk to bugs, build a communication channel with them. Because when you ask correct questions, you will have lots of different answers. And sometimes you will find some surprising answers, like why bugs are not resolved very shortly, or why some bugs are going to production environment. And then to build this proper communication, prepare your environment, customize the tools that you are using to improve your visibility, to improve the granularity, transparency, and improve the communication channel by cleaning your data and using the correct protocol, correct communication channel, correct communication language. And then how can we learn some lessons from bugs? By doing lots of different analysis. It might be going over the type of bug or the components on which the bugs were found, or the status or the number of escape bugs. And there are several metrics that we can study. And finally, of course, for this purpose, we can ask machine learning to do the initial round of analysis for us. And on top of that, we can make the final decision. So thank you so much for listening to me. And if you have any questions, please do not hesitate to reach out to me.
Mesut, thank you so much for sharing your experience, your insight, and also some advice. I can see that there are lots of topics in there that people can look back on and really take note of. So thank you for that.
Thank you.
I'm going to ask the people backstage if we have any questions. What important information can be learned from bugs?
Actually, we discussed throughout the presentation that there might be several information, but in one slide I showed some important questions, which was what, where, when, how, and probably the most important might be why. To understand the root cause of the bug. Why did it happen? What was the reason for that? So if we understand that, because our purpose is not just immediately resolving bugs, but to be able to understand the root cause and in the long term apply the correct fixes, not to have the same bug again and again, right? So asking how and getting this information might be very important.
Talk to your bugs. Do you have another question? How to decide on the severity of bugs?
Again, there are different approaches, but what we did in my team is we decided to two dimensions. First one was the criticality, like if this bug happens, how will it affect the system? Like if it will make all the services down, it will be a very critical one. So the criticality. The other one is the visibility or the probability. Like this is very critical, but the probability is very low. It will most probably not happen in the user's usage ways. So going over these dimensions, we prepare the metrics and decide the final severity. But again, it depends on the approach of the team.
Thank you. Thank you. You've got time for one more, hopefully?
Yeah, sure.
What is the biggest challenge in generating a model for classifying bugs with ML?
This might be challenging, but in my experience, what I can say is optimizing the models, because you are doing the fine-tuning to regulate the inputs or the parameters of the machine learning models. So I had to do several rounds to improve the performance of each algorithm. So this fine-tuning and optimization of the algorithms was one of the most challenging things for me.
Mesut, I'm just having a quick look at the clock there, and we're coming up to time. So I need to say a very, very big thank you. If anybody does have any questions, I know they can still pop them into the chat, and I'm sure you'll spot them and pick them up. Huge thank you to you. Can I just say to anybody who's watching, stay tuned for the next presentation in the A4Q Testing Summit Edition 2025. And also, just if you enjoyed what Mesut had to say, and I know I thoroughly did, then please think about the voting at the end of the summit. Best presentation and best speaker, you'll be able to find that on Mesut's profile on the A4Q Summit website. So again, thank you so much, and thank you to everyone who's listening.
Thank you.
Thank you. Bye-bye.